In this problem we're given a quadratic function expressed as an equation, a table of values, and a graph, and we are to find the domain of the function and write our answer in interval notation. With the toolkit functions in this class, it's helpful to know that we are looking for two possible situations for which an input would be excluded from the domain. So for example, if ever you had to take a square root of a negative number, whatever the input value of the equation is that would produce a negative number under a radical would be excluded from the domain. In this example, there's no radical symbol, so this situation will not present itself. The other thing that we look for in an equation for our toolkit functions is division by zero. In mathematics, if you have a fraction with any number in the numerator but zero in the denominator, whatever the input value is that makes the denominator of the fraction zero would be excluded from the domain. However, there's no variable in the denominator in this equation, so there's no input value to lead us to the situation where we would be dividing by zero. Because neither of these two cases exist, there's no radical symbol and there's no variable in the denominator, the domain of the function will be all real numbers. Because any input value that you plug into the equation, we can just pick one for example, let's pick 4 because it comes out nice, you'll be able to calculate the y value and it'll be a real number. So for example, if you were to replace x with 4 in this equation, it turns out the corresponding output would be 0 according to the table. If you did this calculation, 4 squared 16, 16 times a fourth is 4. Since this comes out to be 4, you'd get 4 subtract 4 is 0. The table shows this in this row. The graph shows this. If you were to go 4 units in the x direction, notice you get to the point 4, 0, meaning when x is 4, the output is 0. So 4 is included in the domain because it corresponds to a real number output. Looking in the chart as a guide, you see that there's no input for which the function is undefined. This is because you'll never be dividing by 0, and you'll never be taking the square root of a negative number. So the domain turns out to be all possible real valued inputs. So one way to write the domain is to just say the domain is all real numbers. But since we are to write our domain in interval notation, to write all real numbers, we say any number between negative infinity and positive infinity, and in interval notation you put a comma between your least and your greatest input values. And since my input values are infinity in this case, you'll always see us using parentheses around infinity because we never include infinity. If you were to include a number in interval notation, remember you'd use a bracket. Even though a graph is always just a finite piece, we are to presume, because the domain is all real numbers, that this graph goes on to the left forever and to the right forever. Oftentimes we put arrows at the ends of the graph to indicate that this behavior goes on forever. For any x value, you'll always be able to find a corresponding y value in this graph. So you just have to have a little faith that if I was to plug in x equals 10, eventually this graph would get extended and you would be able to find, when x is 10, what the corresponding y value would be. With quadratic equations, since their graphs are parabolas, and parabolas eventually grow very quickly, sometimes it's difficult to explain what the domain quadratic is with the graph because they seem to go vertical. So you should just know whenever you graph a quadratic equation, the graph actually never goes vertical. It actually goes to the right forever and to the left forever, even though eventually if you extended this graph far enough, it would seem that it goes vertical. So I wanted to point out that that actually doesn't happen. It never actually goes vertical. The graph goes to the right forever and to the left forever, giving us a domain of all real numbers.